In the previous class, we have seen how to construct the SFD shear force diagram and how to calculate the SF. Today, based on the previous experience, I did some alterations in the explanation and I am covering it past. Then we are going for bending moment diagram. Yes, the problem was to construct the SFD and BMD for the beam shown in the figure. So, it is from the university question paper. First, we need to calculate the support reactions RA and RB. Either you can take moment about A, make it 0, or moment about B, make it 0. As the beam is in equilibrium, total of the moment about any point must be equal to 0. So I am taking the moment about A. Keep the finger at A. 15 into 1 is clockwise about A. And this UDL 15 into 1.5 into 0.75 plus 2. It is again clockwise, and RB into 3.5 is anti-clockwise. Will give me the value of RB equal to 21.96. Now I need to calculate the value of RA. Either you can take total of vertical force equal to 0, or you can take moment about the point B. Vertical force equal to 0, upward I am taking positive. RA is upward, positive, minus 15 into 1.5 plus RB, but RB value is 21.96. If you solve it, you will get RA equal to 15.54 kilonewton. So I got both RA and RB. I am writing the beam once again by putting the value of RA and RB. Now I want to calculate the SFs. I am adopting a different procedure. I am starting from one of the end and reaching the other end. Say I am starting from the left side of the beam. Means from A, C, D, B. I am calculating the SF one by one. To draw the SF shear force diagram, what I told you, what is the procedure adopted? First you calculate the SF at important locations. Which are the important locations I told? Left and right of point load, beginning and end of UDL. These are the important points. for SF diagram. So left and right and point load means we are having the 3-point loads here, 15.54, 15, 21.96. I need to calculate the SFs at left and right of these points. Apart from that, I need to calculate the SF at beginning and end of UDL, that is at D and say the left of B. You cannot calculate the SF under the point load. What is the reason? SF suddenly changes there. It is being the total of vertical forces. Wherever a point load is there, SF suddenly changes its value. That is why we are calculating at left and right of the point load. Okay, when I am starting from the left end, see how I am moving. First I am coming to left of A, then right of A, left of C, right of C, at D, left of B, right of B. This is what the way to complete the SF calculations. Now I am going for left of A. See that diagram, I am putting there a red line that indicates the left of A. It indicates only the location, but calculation you can do by considering any part. Left of A, position you are writing in the calculation, but how you are doing the calculation you are not writing there. So I want SF at A left. Now what I am doing is, as far as possible, I am taking the left part only for the calculation. You can take any part. Right now I am taking the left part for the calculation. Now if you see the left side of A, nothing is there, no beam, no load. Therefore, total of loads on the left side is equal to 0. Definitely if you do it by considering the right side, calculation appears to be bit complex one, but definitely you will get it as 0. If you want, you can practice it. Already we have practiced it. Now from there I am moving to right of A. Yes, just see where is the right of A. That red line indicates where we are calculating the SF. Yes, I want the SF at right of A. Now how I am doing the calculation is, what is there till the left I am calculating? It is 0. Now when I am jumping to the right, what is the new load there? It is 15.54. What it is doing? What is the part that I am doing? I am taking the left part for the calculation. I can do the calculation by left part also or by right part also. Where you are doing that is only you need to mention. I want the SF at right of A, but calculation is done by considering the left part. Are you getting what is mean by considering left part or right part, and left of and right of? Left of, right of, when I say, it says where I want the SF. Right part or left part says which part I am taking for the calculation. As the basic definition of shear force, total of vertical forces on the left part or the right part. You can do any part for calculation. Okay, the simplest way what I am doing till completion of this chapter is I am calculating at one part, as it is being the total of vertical loads, I can add the additional loads to get the SF. Otherwise, for every section individually you need to do it. That will become bit lengthy, but initially you can do it for practice. If you are not getting, you can disturb me at any moment. Okay, SF at right I want, till the left no vertical loads, that is 0. When I am jumping to the right, a new load is coming, its value is 15.54, and that new load is carrying my left part in the upward direction. Therefore, what is its contribution, plus or minus? It is plus 15.54. Therefore, it is 0 plus 15.54 equal to 15.54. Now, from there I am going to left of C. Yes, that red line indicates where is the left of C. Are you getting it? Now again I can do the calculation by considering the right side or by considering the left side. Friends, at any moment you can ask me, sir, give us the check for, say, the right part, you are doing it by left part. Definitely I will give that particular check to you. Yes, SF I want at left of C. So already till the right of A, I know the SF. Just see the figure, any additional load is there between the right of A and left of C. No additional load means no change in shear force. No additional load. To say it, I will contribute 0 to it. So I am writing it like this. SF at C left is equal to 15.54 plus, what is it, till the right of A, and between right of A and C no additional vertical force, therefore plus 0, and final answer is 15.54 kilonewton. From left of C I am jumping to right of C. Just see there, where is the right of C? Now, how we can calculate the right of C? Till the left of C, it is 15.54. What is the additional load between left of C and right of C? It is 15 kilonewton. Now see on what part it is acting and whether it is plus or minus. Yes, it is acting on the left part and is carrying the left down. Therefore, it should be taken as negative, as left up is positive, otherwise it is negative. Therefore, what is the final then? This 15.54 minus 15 will be the SF at right of C. If you want, you can check it. If you are having the calculator, I will tell you the calculation, you tell me the answer. Left of C, right of C. Now right of C, if you are doing the right side, all these calculations I am doing by left side. Right side, if you are observing, how many loads are there? One is the UDL, 15 kilonewton per meter run, and the reactive force 21.96 kilonewton. Now see what they are doing. 15 into 1.5 is the total load, is acting on the right side and is carrying the right down. Therefore, it should be right is down, means left is up. It should be positive. That is 15 into 1.5. Now go for 21.96. 21.96 is acting on the left part and is carrying the left up. 21.96 is acting on the right part and is carrying the right up. Right is up means left is down. Therefore, it will be minus 21.96. Therefore, final answer will be 15 into 1.5 minus 21.96. If you are having the calculator, tell me the answer. Yes. $50.
0.5%.
Yes. Just see. Both the answer are same. Whether you are doing the right part or the left part, you will get the same answer. Only it requires the practice. Rather than the practice, you should understand the concept clearly. Sometimes what happens, say for example, I want SF at left of A. On the A, left no load, SF is 0. But if you see on the right side, so many forces are there and I am saying it 0. How it is possible? You are not respecting yourself. You are not having the confidence over your confidence. That time you will lose the confidence and the things will become the worst. That is why believe the concept and check it by practicing. Yes, SF at right of C I have calculated. Next is SF at D. What he has told? Left and right of point load, beginning and end. For UDL, we are not doing it left and right, beginning and end. And he didn't told anything in connection with the couple. Leave it. Couple will not come in the calculation for the SF. Now, SF, I want it at D. I am again following my own procedure. That is till right of C, I know the SF. And I want to calculate it at D. What are the additional vertical forces I want to see there? Are there any vertical forces there? No. That is why whatever is there, same will be here. Therefore, my calculation will appear like this. SF at D is equal to whatever 0.54 is there, that plus 0. Are you getting what I am doing? Yes, equal to 0.54 kilonewton. Now from here, where I need to go? Left of B. Where is left of B? See there the red line. I want the SF at left of B. Actually, I am doing it by considering the left side part. Here, if you consider the right side part, only one force is there, that is 21.96. It will be easy for you, but already I have done till the D. The same I want to continue. Therefore, what I need to do? Already 0.54 is there with me. What is the new that I need to see? What is the new between D and B? That is UDL. How much is its value? 15 into 1.5. How it is acting? It is acting in downward direction. On what part it is acting? It is acting on the left part. Yes, on the left part means the left will move in the downward direction. Therefore, that SF will be negative. Therefore, it is 0.54 minus 15 into 1.5. You will get it as minus 21.96 kilonewton. Yes, friends, if you want, you can check it by considering the right side. Right side only one force is acting, 21.96. It is carrying the right part up. Therefore, left part is down. It is minus 21.96. Whatever I have done is correct one. Yes, last is the SF at right of B. Means I want the SF at this location. Already I am coming from A. From there only I need to check it. Therefore, till the left of B, it is minus 21.96. And what is the new entry there? 21.96. Now see what it is doing. It is there on the left side of my line and is carrying upward direction. Therefore, it should be plus 21.96. Therefore, final answer will be till the left minus 21.96. When I cross it, plus 21.96. Therefore, minus 21.96 plus 21.96 will become equal to 0. And that is what the expected answer. Yes, this is what the routine procedure that I am adopting my SF calculation. Yes, anybody has got any doubt? Yes? No. Okay. Now you see how I am constructing the SF diagram. What he told, first you calculate the SF at important points, then you draw the ordinates of the SF at those points to some scale. You need not to write the scale there. It should appear, say one value is 21, other one is 0.54. 0.54 should appear as far less than 21.96. He is not measuring it. When he just looks at it, yeah, one is proportional to the other one, something like that, it should appear. Okay, go for construction of the SFD. First I am drawing the zero line. Above it, positive, below it, negative. Now, start constructing the SFD. Either I can move from B to A or A to B. When I am moving from A to B, first is SF at left of A, that is 0. When I am entering into the beam, means I am entering and crossing A, reaching the right of A. It changes from 0 to 15.4. So, to some scale, you draw there a line and write it as 15.5 square, 54. Now from there, next you are going to right of C. See what is there at left of C. It is 15.54. Now at left of C, you draw an ordinate of 15.54. Now SF at right of C, when I cross it, SF becomes 0.54. That line is matching with it, that is why that won't appear here. Now from there, where you are going? You are going to D. What is SF at D? 0.54. Right? At D, plus 0.54 is the SF. Now, you are coming to left of B. What is it? Minus 21.54. Minus means below the line, and you draw there. What he says is, you need not to draw it to the scale. If you observe 21 and 15, 21 must appear greater than the 15. Otherwise, if you are drawing to the scale, lot of time we are wasting for constructing the SFD. You don't expect it to the exact scale. It should appear like that. Okay. Now I need to complete it. Friends, listen to me carefully. From right of A, you are coming to left of C. Why I am saying it? At C, I am having two values. To each value, I need to connect the right of A. Can anybody tell me? From right of A, whether I need to join 15.54 or 0.54, and why so? Yes, you are not getting it. Okay. From the right of A, you have to reach first the left of C, then to the right of C. Therefore, first right of A should be joined to left of C. Therefore, those two lines are to be joined. Now, how to join it? Whether parabolic, cubic curve, straight line, that will be decided by what is the load on the part AC. On the part AC, load is 0. Therefore, in that part, SF is constant. Constant means, y is equal to C. If you have been asked to draw a line, how you are drawing it? That line will be parallel to x-axis. Simply you join it by means of a straight line like this. Yes. Then I am going for right of C. What is it? 0.54. From there I am going to D. What is the value of it? 0.54. Those two are to be joined. But how to join it? Again, see the load in the part CD. If there is no load, here you need to join it by means of a straight line. Just join it by means of a straight line. Means everywhere, if you calculate it, you will get the value is equal to 0.54 is the meaning of it. From D, you are going to which point? Left of B or right of B? From D, you are reaching first the left of D, left of B, then the right of B. Therefore, left of B, what is the value there? Minus 21.96. So I need to join it. How to join it is a problem for me. How to join it, how I am deciding it? First I am seeing the load on it. Load there, if I say at D 1.5 kilonewton per meter run, in between D and B, everywhere it is 1.5 kilonewton per meter run. It is not dependent on where that section is. Therefore, it is constant equal to 1.5 kilonewton per meter run. If load is constant, integration of it, constant integration is constant into x plus one more constant, that is y is equal to ax plus b. Means if UDL is there in the shear force, it will be an inclined line. Y is equal to ax plus b is an inclined line cutting the y axis at a distance is equal to c, is the meaning of it. Here only we need to understand what is the meaning of that variation, how I need to connect it. If you don't want to give the trouble to your brain, directly you see the load there, UDL here inclined, no load parallel, like that also you can remember. On that part, if no load is not there, here the line will be parallel. If UDL is there, load will be inclined. If inclined load is there, it's like integration of ax plus b, ax square plus bx plus c. It will be a parabola. Therefore, here load is constant. Here it will be an inclined line like this. This completes the shear force diagram, not complete one, but this shear force diagram will be useful for us in construction of the BMD. That we are seeing after constructing the BMD diagram. Now I will go for, yes, anyhow, SF above the line is positive and below the line is negative. Now go for BM calculations. What he has told in connection with the BM? Where all you are calculating the BMs? BM at left and right of the couple, at point load and start and end of UDL. Yes, with that as the concept, where all you are calculating the bending moments here. Bending moment you are calculating at A, at C, at D, at B. Why you are not calculating left and right? At couple only the bending moment suddenly jumps. Therefore, at couple I need to calculate it at left and right. Otherwise, there is no necessity to calculate the BM at left and right. Okay, we shall go for construction of the BM. Calculation I will complete. Yes, first is BM at B. Here, as in case of the SF, I am calculating till certain point and I am adding or subtracting. It was only the load. Here, load into distance. That is why I cannot add or subtract as in the earlier case. Directly I have to calculate everywhere. Only to reduce the effort, you can decide which part is to be taken for the calculation. First is BM at B. Yes, if I see the left part, so many loads are there. Better to do the calculation by considering the right side. What is there on the right side? No load, therefore BM there equal to 0. Next is calculate the BM at D. Either you can calculate by considering the right part or by considering the left part. Tell me which part you prefer here. Yes, friends. I am preparing the left part. Yes, see the bending moment by considering the left part. Yes, 15.54 into 2 and is sagging positive minus 15 into 1 is hogging negative. Tell me the number. 15.54 into 2 minus 15 into 1. What is the number that you are getting? If I consider the right part, it will be bending moment at D 21.96 into 1.5 is positive minus 15 into 1.5 is the load. It will act at a distance of 0.75, 1.5 by 2. If you simplify it, you will get it as 16.06 kilonewton meter. If you check it on the other side, you should get the same number, that is 15.54 into 2 positive minus 15. Next is I need to calculate the bending moment at C. Now it is prepared to go for the left side. Only one load is there. Keep the finger at C. 15.54 into 1 is going hogging sagging. That is why it is positive. If you want, you can check it at the other side also. Bending moment at C is 15.54 into 1 is equal to 15.54 kilonewton. Now last is the bending moment at A equal to 0. Now I need to complete the bending moment diagram. Yes, to complete the bending moment diagram, first bending moment at C, bending moment at A is 0, bending moment at C is bending moment at C is 15.54, bending moment at D is 16.06. Bending moment at B is 0 and bending moment at D is 16.06. So I have drawn there 16.06 and 0. I want to join these 2 points. How to join it? For that, either you see the shear force diagram or you see the load. If you are seeing the shear force diagram, listen to me carefully. If you are seeing the shear force diagram, how the line is? Inclined one, first order in X. Therefore, what is bending moment? Integration of first order. That is nothing but second order parabola. That is a curve. I need to join these 2 points by means of a curve. That curve I can draw it any fashion. That is why I am in need of one more point on that curve so that I can draw the curve correctly. Anyhow, it is parabola. See, when you are drawing, say Ganpati, you need not to write at the bottom which god it is. If you are drawing the figure of other gods, that time you have to write the name of that god. Are you getting what I want to say indirectly? Ganpati is unique in his shape. That is why you need not to mention there. Everybody can understand. But for other gods, uniqueness is not there. Like that, for drawing the straight line, you need not to say it as a straight line. But if you are drawing the other lines like parabola, cubic curve, fourth order curve, fifth order curve, the confusion will be there. What will be the shape of that particular curve? That is why, at least to the examiner, we need to say that it is second order curve or parabola or cubic curve, fourth order curve. Like that, we need to mention there. That part I will tell it afterwards. Now I need to complete the other part. Like the bending moment at A is 0, bending moment at C is 15.54. These 2 points are to be joined. How to join it? Either you need to take the help of the shear force diagram or the loading. Shear force is linear, sorry, parallel line. Shear force is constant. Integration of constant is linear, straight line, inclined line. Therefore, these 2 points directly I can join it to the straight line. Like that, if you go for bending moment between D and C, at D it is known to me, at C it is known to me. I need to know the variation of bending moment between D and C. What should I do? Go for shear force diagram or go for the loading. If you go for the shear force is constant, indicates bending moment is changing linearly. Linearly means straight line. Therefore, I am joining it by means of a straight line. Now comes the important point, which will be expected in the examination. Usually, will ask you complete the shear force and bending moment diagram with important points on it. He won't tell you the important points that you need to decide. Okay. Now I want to join that 16.06 and 0, whether I need to draw a concave curve or convex curve. For that, I am in need of what will be the maximum or minimum value of the bending moment in between D and B. Already we know that M is equal to dF by dx. Bending moment is equal to rate of change of shear force. Sorry, F is equal to dm by dx. When the value of m will be maximum, y is a function of x. For what value of x, y will be maximum? For that, we need to study the maxima or minima. If y is a function of x, for y to be maximum, dy by dx must be equal to 0. Like that, here f is equal to dm by dx. For m to be maximum, dm by dx must be equal to 0. But what is the value of dm by dx? Is equal to f. Therefore, m will be maximum where f is becoming 0. M will become the maximum where the f is 0. Now, you just answer me one question, I will conclude the today's lesson. Just by seeing the figure, SF figure, can you tell me, is there any point of zero shear in the SF diagram? Yes, unmute the mic.
Yes, sir.
It is
Point
there.
A and B.
It is between D and B. What is the
Yes, sir.
reason? At B it is negative and at D it is positive. Therefore, somewhere it is 0. I need to trace out that point and I need to complete the pending moment diagram. Friends, from the last two class we are going for a single problem. So my intention is solve the single problem in depth, understand it. Then rest of the problems we can solve like anything. Yes, anything to ask here before concluding the session? Yes, friends.
No, sir.
Okay. Thank you, friends. Now we'll conclude the session.